Right, so now we're going to take a look at horizontal motion, and as we're going to see, horizontal motion usually involves friction along a surface, and if that's the case, then we're also going to have to think about the vertical forces as well, and you'll see that in the examples that we'll look at. We'll look at an example very similar to the ones that we would have seen in the first year course, and then we'll see how things bump up a little bit for the AP course, working our way beyond. So these pictures here show some different arrangements of forces, and the first two look like they're the same, but remember that the key factor here is which way the object is moving. So in the first case, if the object moves to the right, but in the second case, if it moves to the left, that would change the way that we think about F equals ma. In the first situation, we would set up our equation as F1 minus F2 because the F1 pulls it in the positive direction, so we list that one first. But in the second picture, if the object moves to the left, we would choose to write this as F2 minus F1. Now again, that is a choice that I suggest that then makes sure that A, the acceleration, sort of matches our intuition that a positive acceleration means speeding up and a negative acceleration means slowing down. So in these next situations, again, it's the same thing. This is how we would write this first one here, F1 minus F2, if our object is moving to the right. But if the object is moving to the left, then we would do it this way. So the F equals ma equation does not really tell you which way the object is or what the object is doing. It doesn't describe the motion. It describes what's affecting the motion. So again, I would suggest that you choose the positive direction as the direction of motion, whichever way V points at the beginning of the problem, and then be consistent with that for the rest of the situations. This last one is a case where F1 and F2 are equal to each other, and so we could just say that the forces add up to 0. You could say F1 minus F2 equals 0. You could say F2 minus F1 equals 0. You could just say F1 equals F2. All right, so again, classic situation that we've talked about in the past in our first year class. So I've just diagrammed the picture here for a block being pulled to the right with a force of 14 newtons. So that's our applied force here. And there is friction. So let's recall how to deal with friction. Friction depends on two things. It depends on the types of surfaces involved, and that's represented by mu, which is called the coefficient of friction. There's officially a coefficient of kinetic and a coefficient of static friction. At this point, we're just dealing with kinetic. Things are moving. And then F sub n is the normal force. And what happens when we first start learning physics is that our situations are rather simplistic, and the normal force and the weight force always tend to balance each other out. And so we don't even think about the fact that in the y direction, we're saying that the object isn't moving, and so all the forces balance. And so that is why the normal force minus mg equals 0, or the normal force equals mg. We're going to see that that's going to change in the next question, and that's, again, one of the things that we got to look for in our AP course. But the second part of it is based on what I was just talking about on the earlier slide, that in the x direction, our acceleration is going to be found using all the forces acting in that direction. So it's pulled to the right, so the motion is to the right. And so we would say that the applied force minus the frictional force is equal to m times a. So then we can begin to put some pieces together here. Our applied force is 14. Our frictional force is mu, that's this coefficient here of 0.2, times our normal force, which we have figured out here is m times g, so that's going to be 4 kilograms times 10 newtons per kilogram, so 40. And that equals our mass in kilograms, which is 4, times our acceleration. So we would take 14 minus, this comes out to be 8. 14 minus 8 is 6. 6 divided by 4 is 1.5. And that would be to the right if we were asked to give a direction as well.